Don't operate the computer if you don't know what you're doing. Don't investigate the computer if you don't know what you're doing. Don't work on the raw data if you're going to investigate the system because you may be tampering with the evidence. If you're going to work on the raw data or the original evidence, you need to know what you're doing and you need to understand the implication of your actions. So you can explain it and they can differentiate your own actions from the actions that were done before you got hold of that system. ACPO, 4 principles. I do believe the ACPO principles are really due for a change or upgrade. Considering all the new technology, they definitely need to upgrade this. They've only changed the name to NPCC from ACPO, but they need to actually change the guideline. It's a guideline that helps you maintain admissibility of evidence or preservation of evidence or integrity of evidence, which is don't operate the computer if you don't know what you're doing. Don't investigate the computer if you don't know what you're doing. Don't work on the raw data if you're going to investigate the system because you may be tampering with the evidence. If you're going to work on the raw data or the original evidence, you need to know what you're doing and you need to understand the implication of your actions. So you can explain it and they can differentiate your own actions from the actions that were done before you got hold of that system. If I'm here and I can see the person is working, this is a crime scene, and I can see that the person was doing something really nasty, but they're trying to close the applications quickly, and I don't have my camera here, but I need to preserve the evidence. And the applications are running. So let's say they are running on the system, and I can see a flash drive plugged in where they are running the applications from. The moment they pull that hard drive and shut down the system, the evidence is gone from the system and also gone from the memory, which is volatile memory. Because the moment you shut down your system, volatile memory is gone. Your RAM is volatile memory. Things that are not permanent. You shut your system down, they disappear. That is volatile memory. So I see that, but your running applications are stored in the RAM, in the volatile memory. They are not stored on your hard disk. Sometimes when your RAM is full and your applications are suspended, some of them will sit in the hard disk temporarily until there's space in your RAM again and you click on those applications, then they come back to your RAM. But while your application is running, all these things you're seeing on my screen right now, they are running where? On the RAM. So if I want to see what the person was actually doing, all the applications running, all the processes running, where do I investigate? The RAM. But I can only investigate the RAM while the system is live. But if I'm investigating that system while it is live, I need to be careful because my own actions could also tamper with the evidence. But if the situation really warrants it, and I have the necessary warrant or authorization to investigate that system as necessary, and I know that's the right thing to do, I need to capture as much evidence as I can. If I've got a camera, take pictures of what was going on the screen. If I'm able to copy what was going on the RAM, connect my device, use my tools, store the content of the RAM somewhere, and then investigate later with my forensic software. But in the process of doing that, even though I'm trying to collect important evidence, I've still changed something on the system. So according to ACPO, I should be able to explain the implications of my actions. So they're able to differentiate my actions from the actions of the suspect before I got hold of that system. Otherwise, the evidence may also be inadmissible. So another way is if I'm installing FTK Imager, for example, and I'm installing it directly on the system because I don't have a write blocker there with me, but I need to capture the evidence. I need to collect the evidence on the hard disk. When I install FTK, I've changed something in the registry. I've altered something. So I need to be able to explain that because I installed FTK to collect the evidence, this is a change that happened because of me. Any other thing was not me. But you need to be able to explain the implication of your actions. That's that. And then the person in charge of the case is responsible for ensuring the first three. That's the idea of ACPO. Documentation, very important. Document everything in such a way that it is repeatable. So if another forensic analyst comes, they are able to repeat exactly what you did and get the same result. Your JPEG file has a file signature of FFD8FF. There are tables also of file signatures. What is a file signature? File signature is like the DNA of a file. What does that mean? I can change the extension of a file, but it's way harder to change the signature of the file. The file signature is what lets you know what kind of file it really is, or what lets your computer know what kind of file it really is. Now you can deceive your computer or your security solutions, many security solutions, by changing the extension or through steganography, hiding of the file inside the file. But with the file signature, you can tell if something is not right. So this is called an extension mismatch, where the extension of the file does not match the file signature. So if I see .pdf and I receive .pdf in my email, but then I do a forensic analysis and I see ffd8ff in the file signature, that lets me know there's something wrong with this file. It's probably malware disguised as legitimate file, because they've masked it, they've disguised it as a PDF file for me to double click and read something, but it's actually a picture, which could be malware. So it lets me know. Also, criminals use this method to hide naughty content. So when they want to send naughty content to each other sometimes, or when they are storing naughty content on their PCs, on their computers, they might change the file extension. So when you double click it, it's not opening. If you store your JPEG file as PDF, most likely it's gonna open in Adobe, but it's not gonna show anything. It might show an error. That's because even though you've changed the extension, the computer is still not processing, it's still not understanding how to process that information. If you check the file signature and you then see it's ffd8ff, now you know that I need to change the extension back to .jpg and then open it. But your forensic tool sometimes will just show you the hexadecimal of the file. So in the file header, when you click on the file in your forensic software, in the file header is going to show you the file signature first. So the first hex values you're going to see would be the file signature. So for example, if all of you send me a JPEG file right now and I click on everything, different JPEG files, the beginning of all the JPEG files that you send to me will be what? ffd8ff, then other properties will come. Because that is the file header. It tells me the type of file it is. It tells the computer the type of file it is. Now I can change the extension, but it doesn't change the signature. And this is why I refer to the file signature as the DNA of the file, because when you do face surgery, you're changing your face, but you're not changing your DNA. You're still you inside, your DNA is still the same, but you've changed your face. That is what extension mismatch is, or when you change the extension of a file, but you don't change the file signature. Which is why the signature is a more reliable way to identify what kind of file it is when you're doing forensic investigation. Chain of custody, I already explained this. This is how you maintain or ensure that the evidence retains integrity. It's not been tampered with. Or if it was tampered with, at what point did it change? Digital evidence, for example, you hash it each time it's changing hands. So they can say, okay, what was the hash when you collected it? Is it the same as the original? Yes, sign. This is what I collected. When you are handing that over to the next person, you give them the hash, they hash it right there. Is it the same as the one you're giving me? Nothing has changed? Sign. But if anything has changed, they also need to log it and be like, at this point, this is the hash of the file. Then they know where something changed or where it was tampered with. That's the point of chain of custody. Anti-forensic techniques, some of them include hardware devices. Anything that tries to avoid or evade forensic detection is anti-forensics. VPN, tunnels, your rubber ducky, your OMG cable, your screen crab, all those devices, they are in a way anti-forensics, especially for those forensic analysts that don't know about them, because they won't know what to look for. And they leave very minimal traces on the system to show what actions they've carried out. So those devices can be used to carry out actions, but then you wouldn't know that it was the devices that carried out the actions. You would think it was the user of the system. So that, in a way, is anti-forensics, because you can't reliably distinguish the actions of those devices from the actions of the user. And that could make you deal or punish the wrong person. So that's anti-forensics. Encryption is also anti-forensics. Steganography is anti-forensics. Things that let you make forensics life difficult. Incident response framework. This is by NIST. Preparation, detection, and analysis, which we already spoke about. You prepare for, you don't prepare after. Your detection, you detect it, you control it, you contain it, you eradicate it, but before you wipe it, collect the evidence. That's the eradication. And then recovery. Recovery is complete after you return to normal business operation or your production environment. Post-incident activity includes things like lessons learned. How do you feed that back into your plan, your preparation? Volatility is how quickly data disappears from the memory. Your RAM is volatile. You shut your system down, it is gone. And there is evidence that are in order of volatility. Your hard disk is more reliable, for example, because it's not volatile. You shut down your system, the files you stored are still there. But if you're working on the Microsoft Word file and you've not stored that file on the system and your system shuts down, what happens? It's not going to be on your hard disk, but sometimes because of the way Microsoft Word has been built now, it may store a temporary version, but it's not going to be the most up-to-date version, depending on the time your system shut down and the time you made the last changes. So what you're Microsoft Word is just doing is storing that information in a temporary file, which is why there's a name that it gives to it automatically, auto recovery. So automatically it gives that to it. But if it's not stored on your hard disk and it's stored in any other volatile memory, the moment your system shuts down, it is gone. Order of volatility, which ones disappear first, which ones disappear last. You can see the hard disk is the number 6, a bit more stable. But you can see registers and cache are the most volatile. Then you've got your RAM next, and then network state, kernel, and then temporary file system.